Good morning, dear all students. Here we are going to discuss about some of the applications of Pascal's law and hydrostatic law. So here you can see that Pascal's law, one of the example of Pascal's law, where we can lift a car with a small force which we are pushing with our thumb. It will push the car total weight upward. So what is the formula they have used? That is pressure remains same at same height at 1 and 2. 1 and 2 you can mark the section 1, section 2 you can see where section 1 will be marking with section area of that section 1 will be small compared to section 2, but pressure exerted or experienced at the same height, same fluid, closed chamber, then pressure will be same. So whatever the weight acting over that surface, it is irrespective of weight, the pressure remains same. Using that same pressure and varying the area, we can vary the force. For smaller area, we need to apply larger force to keep the pressure same. So for a larger area, we need to apply very small force to keep the pressure same. So we are using that particular system for lifting car. Okay. So here you can see that the uh, technique we are using to lift the cars in uh, workshop using Pascal's law. Okay, fine. So now we will go to hydrostatic law, where we can see that um, what is written there. Pressure is produced by the weight of the fluid above the surface. This is what we explained in the hydrostatic pressure or hydrostatic law, where at the point X, what is the weight exerted by the water or air column or water column. If it is air, then air column, or if it is water, then water column. So weight of the air in the column applies pressure to point X. Okay, so this is the surface and this much weight. How we calculate weight? If you know specific volume, specific weight, then we can multiply with total volume. We will calculate. We can calculate the weight. Okay, water column. Or rho GH, density into gravity into height. So pressure of fluid depends on the depth. So here you can see at what speed the fluid is coming out of these tubes or holes at the lowest point. Maximum pressure it will experience. So it will more travel larger distance or with larger velocity it will eject out. Here velocity decreases. Here with respect to height, pressure decreases and velocity decreases. Okay, fine. So depending upon the height or depth, fluid will flow. So here, whatever the shape, irrespective of the shape, the pressure will remain same at the bottom surface. Since everywhere the total height of water is same, but the shape of the vessel is different, but it is connected at the bottom. So whatever pressure exerted or experienced here because of this much water, it will be same. Even more water it is exerting or less water it is exerting, pressure will be same. Pressure only depends upon height, not shape or volume of liquid. Here, more pressure at greater depth. Here, same quantity of water with a shallow lake. In a shallow lake, 5 meter only depth. What is the pressure felt to this point? At this point, it will be rho into g into height of a 5 meter. But same quantity of water in a more deep lake. So, what will be the pressure exerted here? It will be same quantity of water. That doesn't mean that here the pressure will be same. No, depends upon the height. Since it is 10 meter below the surface, free surface, both sides same free surface, but pressure will be larger here for same quantity of water because it depends upon height. Okay, fine. Now there is a problem. So finally, we reached what if the PPT was the atmospheric pressure and gauge pressure, absolute pressure, vacuum pressure are differentiated. How we can differentiate these things. Okay, fine. So now there are various types of pressures and absolute pressure. What is absolute pressure? Absolute pressure is defined as the pressure which is measured with reference to absolute vacuum pressure. Absolute vacuum. What is mean by absolute vacuum? Very important point. As what is mean by absolute vacuum? It is vacuum pressure with zero gauge pressure. Zero pressure. Nothing is there. No molecule, no atom, no neutron, proton, electron, nothing. Very void. Very difficult to Very difficult to imagine such situations. In space, even in space also, something will be there, radiation will be there, some electromagnetic radiation, photons will be there. Okay, absolute zero means nothing. Okay, so big zero. So from that, that is the reference, that is the absolute pressure. Nothing. Pressure will be minimum. Minimum means not minimum zero. Zero Pascal. Difficult to get zero Pascal. Okay. So slowly, if we go upward, then more pressure increases, more fluid atoms will come into picture. We will add one molecule, one atom, then slightly that will get scattered. It will collide with the walls and create a pressure. And if you have more number of fluids or atoms or electrons, then it will collide each other and it will create more pressure. So slightly depending upon the quantity of more atoms, molecules present in particular unit volume, then pressure will be different. Okay, pressure is nothing but collision happening between the molecules and on the walls of the container. So how the walls experience pressure because of the collision of the molecules on the walls. Okay. So there is two types of pressure. One is gauge pressure, one is vacuum pressure. What is gauge pressure? Then what is vacuum pressure? Gauge pressure means something we measure just above atmospheric pressure. We are keeping atmospheric pressure as a reference or diatom pressure. Then whatever, how much higher than the atmospheric pressure. Atmospheric pressure is 1 bar and our tank pressure is 2 bar. So what is the gauge pressure? That is our tank pressure, absolute pressure is 2 bar. Then what is gauge pressure? That is 1 bar we will neglect because we will reduce that to atmospheric pressure. We will keep the atmospheric pressure data. Above atmospheric pressure, how much is the bar? In addition to that, one more bar is there. That is so gauge pressure is 1 bar, absolute pressure is 2 bar. Okay. So how we will calculate mathematically? There is a relation to calculate the gauge pressure from the absolute pressure. So you can see the arrow represent the gauge pressure. So you can see two arrows. Two, no, one, two, three, four, five main arrows are there. What is the axis? Absolute zero pressure. Sorry, this axis is nothing. From the axis we are just measuring, but the x-axis is very important. Pressure is shown on the y-axis where there is pressure. That this point represents zero absolute. That is zero pressure. That means absolute zero pressure. Okay. So from that, whatever it is, whatever value we are measuring from the absolute zero, that is absolute. So there are, you can see gauge pressure. Here there is a gauge pressure which is measured above the atmospheric pressure. Okay, any pressure which is measured above the atmospheric pressure, that is gauge pressure. Any pressure which is measured below the atmospheric pressure is vacuum pressure. So if you are saying there is a vacuum pressure of 1 bar means that is absolute zero. That is 1 bar reduced below the atmospheric, it's gone to minus 1 bar. Minus 1 bar means absolute zero only. Absolute pressure of pressure. Okay, fine. So whatever 0.5 bar minus 0.5 bar means it is less than 1 bar is the atmospheric pressure and the present pressure inside the chamber is 0.5 only. That means less than 1 bar. So vacuum pressure is it is vacuum pressure. We can just imagine from the values. Okay. And this is the reference line. If you are keeping the reference line as atmospheric pressure, then whatever pressure we are measuring above the atmospheric pressure, that is gauge, and water pressure we are measuring below the atmospheric pressure, that is vacuum pressure. So P absolute is what? This is P absolute. So P ATM, this is P here, it is P atmospheric pressure plus gauge. That is what it is written here. P atmospheric plus P gauge is the P absolute pressure. And the gauge pressure, it is defined as what? Gauge pressure, it is defined as the pressure which is measured with help of a pressure measuring instrument in which the atmospheric pressure is taken as data. Vacuum pressure, it is defined as the pressure below the atmospheric pressure. Vacuum pressure is equal to then atmospheric pressure minus absolute pressure. So here from this equation, from these two arrows, you can calculate the vacuum pressure. Vacuum pressure is what? Atmospheric pressure minus this value. So which is the highest value here? Atmospheric pressure is the highest value. If in minus the absolute pressure, then we will get the difference between the distance between these two. Or you can write absolute pressure plus vacuum pressure will give atmospheric pressure, or atmospheric pressure minus absolute pressure will give vacuum pressure, or atmospheric pressure minus vacuum pressure will give absolute pressure. So this is very simple. Okay, this particular session explains about the difference between the applications of Pascal's law, applications of hydrostatic law, and what are the different or how we can differentiate gauge pressure, atmospheric pressure, vacuum pressure, and absolute pressure from each other. Okay, thank you so much.